Hallo, it's Dumplet here. Here's an item on number theory. Find the number of ordered pairs x, y of integers, so x and y are integers, such that x squared plus xy plus y squared is equal to 28. Credits to the Princeton University Math Contest back in 2009 for this item. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. So, we can do some pretty easy observations here, I guess. Because, first of all, if I take a look at the given equation, x and y are integers, but I have two squared terms, the x squared and the y squared. So they really have an upper limit as to what the values can be. So for example, x squared and y squared, they're both non-negative, so I'm pretty sure they cannot go that high. But the problem is we have integers, so this xy term is actually the problem. So we cannot really use bounding just by using the logic that, x squared and y squared cannot be that big because xy might be negative. So we have to do some other ways to tackle this problem. Now I'll show you guys two ways. Now this is the first method. So the first method is to take a look at this equation as a quadratic equation. Now, there's a reason why we can do this because, I'm going to write this as x squared plus yx plus y squared minus 28. So, take a look at this. I'm writing the coefficients in green, and this is essentially a quadratic equation in x. So, we can try to solve for x in this quadratic equation. So, but why do we want to use this? Is because, x is an integer. Now, we know the quadratic formula, negative b plus minus square root of b squared minus 4ac. That's equal to 2a. That divided by 2a, that should be equal to the value of x. Now, we take a look at this equation, but we know x is rational. X is an integer, so x must be rational. So x is a rational number. So we want this to be rational as well. So what makes this number not rational? It's this discriminant over here. So we can try to use the discriminant, and we have to get that the discriminant must be a perfect square. Otherwise, the value of x here will not be rational. So we have to check for the discriminant being a perfect square, or a square of a rational number. So let's try to get the discriminant first of this quadratic equation. So if I try to get the discriminant of this quadratic equation, it's going to be y squared minus 4ac. So 4 times 1 times y squared minus 28. And this should give us a rational perfect square. So k squared, let's just say it's equal to k squared. Now, k is actually going to be a positive integer because, this thing on the left is an integer because y is an integer. So we can try to solve for this. We can try to solve for integer values of k and y. All right. So let me just simplify the left side here. I'll get y squared minus 4y squared plus 112. That's going to be equal to k squared. So I'll have 112 is equal to k squared plus 3y squared. Now, we can try to bound the value of y first because, with this, we know k and y are non-negative. So we have 3y squared less than or equal to 112. We're going to get y squared is less than or equal to 112 over 3. That's equal to 37 1/3. So we just have to list down perfect square values for y squared. So we know that y squared can be of the following values: 0, 1, 4, 9, 16, 25, and 36. And we just have to check which of these values will give a perfect square value of k. Now, here's a little bit of trial and error. We just go for the values of k by substituting the values of y one by one. So let's try the following. Now, we have to substitute into this equation. Remember that. So let's try y equals 0. If y equals 0, you're going to get k squared. It's going to be 112. So 112 for the value of k squared. Now, that's impossible for k squared because 112 is not a perfect square. Next, if y squared was equal to 1, then k squared here would be 109. Again, impossible, because 109 is not a perfect square. Next, let's try y squared being equal to 4. Now, if y squared was equal to 4, then we're going to get k squared is 100. That's possible. So we have to, let me just encircle it, knowing it's possible. And we just have to do it for all the values of y. If if y squared is equal to 9, I'll be getting k squared here. That's going to be equal to 85. 85 is not a perfect square, so we remove that. All right, let's try y squared being equal to 16. If y squared was equal to 16, then k squared would be 64. That's a possible value. All right, next let's try 25. If y squared was 25, then k squared over here would be 37. Now 37 is prime, so it's impossible here. That's going to give 37, so we disregard that. And if y squared here was equal to 36, k squared would be 4. And 4 is a perfect square, so we could consider that. All right, now we don't really need the value of k because we just have to list down the possible values of y. So y squared, I'm sorry. So y squared, as we got, that's going to be 4, 16, and 36. And take a look, we're not asked for the value of y, we're not asked to get the values of y and x, we just have to count how many. So let's take a look here. So for each value of y, I'm going to get a corresponding value of x. In fact, for each value of y, since I have this one, right? Since I have a quadratic equation for x, for each value of y, I'm going to get 2 solutions for x because the discriminant is not 0. The discriminant is going to be 164 or 4. So the discriminant is not 0, it's greater than 0. So we're going to get 2 different solutions for x. So one value of y squared, it's going to give 2 values of y. So 2 values for y. And we know that each value of y, it's going to give 2 values for x. So that's going to give us 4 solutions for y squared equals 4. We could do the same logic for the 16 and the 36. That's going to yield 4 solutions each. And that's the reason why if I add the 3 4s, I'm going to get 12 solutions, right? Again, we don't really care about the solutions. We just have to count how many. That's the reason why I'm skipping the process of solving for x, because we can kind of just use logic of quadratic equations and the respective values for y that we got, right? That's the first method. Let's talk about the second way to kind of help us get the values of y. Now, we can try to complete the square. Now, although it's not obvious how we complete the square in this case, let me try to show you this method because, again, it's not that obvious, but if we multiply both sides by 2, I'm going to get 2x squared plus 2xy plus 2y squared. That's going to be equal to 56. And this part is actually a sum of 3 squares. It's the sum of x squared, it's the sum of y squared, and it's the sum of x plus y squared, like this. And that's apparently equal to 56. Then here we could restrict the value of both x and y. Not as good as the previous one because we could restrict, for example, in this case, y squared being less than 37 and 1/3. But at least in this case, we could get x squared or y squared. Well, they're both less than or equal to 56. Now that we have 3 non-negative numbers, we're taking the sum of non-negative numbers. So we would know that both x squared and y squared, so they're both less than or equal to 56. But we could just we could just list down all the possible values of x squared and y squared. So that's going to be the perfect squares from 0 to 7 squared, and that's going to be true for both. Now we're going to technically go through the same process of doing the substitution for probably x squared and y squared and just realizing which of these values should work. I mean, I'm kind of skipping a lot of details here, but eventually we should be able to get the same thing. Let's just say we try the values of y. We should be able to get that the possible values of y that's going to work, it's going to be the 4, the 16, and the 36, right? So we're still going to get that the only possible values of y squared here is going to be 4, 16, and 36. And as we mentioned in the previous part, that's going to give us 4 solutions each, and that's going to give us 12 solutions. So I'm just kind of showing you the alternative way to kind of reach the bounding. But nevertheless, even if you use the first method or the second method, we should be able to get that. There will be a total of 12 solutions. There are 12 ordered pairs for x comma y. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye.